Hey guys, welcome to the video where I'll be screening and testing our athlete for different sports. First, we'll be starting with a postural analysis, a fundamental assessment for all athletes. This helps identify imbalances and potential injury risks by evaluating the relationship of different joints and body parts to each other. The procedure here is to have our athlete stand in a relaxed posture with shorts while being barefoot. The athlete should stand a sufficient distance away to allow for an adequate view of their posture. And to have an accurate assessment, we'll need an anterior, posterior, and side view of the athlete. Looking at shoulder symmetry, the shoulders appear to be level when viewed from the front and back. When looking at the roundness of the shoulders in the anterior and side views, there is a visible internal rotation particularly prominent in the side view. This indicates potential underactive muscles in the upper back and rear deltoids, as well as overactive muscles or tightness in the chest and anterior deltoids. Observations of thoracic spine alignment of the athlete entails slight head forward posture, which is associated with thoracic kyphosis, where the head juts forward, placing extra strain on the neck and upper back muscles. When observing the posterior view, there appears to be no noticeable lateral curves. The shoulders and hips are level, and there is no rotation or tilting of the vertebrae. Observations of the side view, looking at lumbar lordosis, there is a natural inward curve of the lower back. This is typical and expected for a healthy spine. Finally, now looking at the knees and feet, there appears to be no hyperextension of the knees, and the feet are in a neutral position. Next up, we're testing flexibility for a marathon runner. Flexibility is crucial for injury prevention and overall running efficiency. Our first assessment is the modified Thomas test, which is used to assess the flexibility of the hip flexors and the knee extensors. For this test, a plinth bed and a goniometer is used. The procedure for this test has the athlete seated on the end of the bed. They then roll back onto the bed and pull their opposite knee to which is being tested to their chest. The athlete then holds the contralateral hip in maximum flexion with the arms, while the limb to be tested is lowered towards the floor. The angle of hip flexion measured for our athlete was 180 degrees on both left and right sides, and the angle of knee flexion measured was 113 degrees for, again, both sides. This indicates that our athlete has symmetrical range of motion, which is good for injury prevention. Our second assessment is the ankle dorsiflexion test, which is used to assess the dorsiflexion range of movement of the ankle and indirectly measures the calf muscle. For this test, the athlete places one foot forward so that a line through the heel and the big toe of his foot are aligned on a tape measure on the floor. The athlete is instructed to lunge forward so that their knee touches the wall. While the knee touches the wall, the heel is to stay in contact with the floor at all times, and the athlete is able to hold onto the wall for support. The maximum distance from the wall to the tip of the big toe is recorded in centimeters. Our athlete here recorded a score of 9.5 centimeters on the right and 7.5 centimeters on the left. This indicates asymmetrical dorsiflexion, which affects the athlete's running stride and increases risk of injury. This may be due to calf tightness or a previous injury the athlete is recovering from. Normative values for this test is a mean value of 13.9 plus or minus 3.8 centimeters, for which our athlete is below on both sides. Our next assessment is for swimmers and is the shoulder mobility test, which assesses the flexibility and function of the shoulder joints, ensuring they can move efficiently through the water. We first measure the length of the participant's hand. They then need to make a tight fist with both hands. The one arm should reach up and the fist should reach down from the back of the neck to the rhomboid area. The other arm reaches from the back upwards towards the scapula. We then measure the distance between the fists, specifically from knuckle to knuckle of the second finger. Our athlete had a hand length of 19 centimeters and when testing got a measurement of 22 centimeters and 30 centimeters. This gives him a score of 1 out of 2 as the fists are 1.5 hand lengths from each other. Our next assessment is testing for strength and power for a cricket player. We use a broad jump here, recording the distance jumped, which reflects the player's leg strength and explosiveness. Our athlete recorded a distance of 2.26 meters. Next is speed and agility for a soccer player. Speed and agility are vital for soccer players. We use the 40-meter sprint test, which evaluates the acceleration and top speed, essential for quick movements on the field. We time the sprint to assess the player's speed and performance. Our athlete recorded a time of 6.63 seconds. Finally, for our last assessment, we're testing rugby players' cardiovascular endurance. For this, we're doing a broncho test, which measures their aerobic capacity and endurance. Here, the athlete runs back and forth between cones set at 20, 40, and 60 meters, completing 5 laps as fast as possible, and the time taken to complete the test is recorded. This test challenges the player's stamina, simulating the high-intensity efforts required in a rugby match. Our athlete managed to complete the test with a time of 7 minutes and 24 seconds, which leaves lots of room for improvement as normative values are between 4 and 6 minutes. All these assessments provide valuable insights into an athlete's strengths and areas for improvement, helping tailor their training for peak performance. Thanks for watching.